Hello everyone and welcome back to another episode of BTech. Today we're going to be looking at Runout from a few different types of ways of mounting different pieces on your mill. In this case, we're going to be mounting an 11.5 millimeter end mill to the Harbor Freight mini vertical milling machine, drilling machine. You can see here the part number. These are pretty common because you can get them from about $800 over at Harbor Freight. There's lots of reviews on these online. Here, the main thing we're going to be testing today is how well does the chuck that comes with the Harbor Freight do in terms of runout compared to some other options. Now, the chuck that comes with it, as you can see here, really doesn't have many markings on it. It says 1 to 13 millimeter, JT33, and that's about the only marking I can find on it. As you can see, it's a keyed chuck. This is the first thing we're going to be testing. And immediately what you can see here is that this chuck does not have an integral arbor. So the arbor is still mounted. There's an R8 draw through arbor for these Harbor Freight mini mills. So I left it there because I wanted to see what is the runout on the arbor itself. Then we can put the chuck on with the end mill and see how it does there. And then we can compare it to some different options that I have. Now, immediately when I got this, I knew that I was going to have to upgrade a lot of the parts, in addition to doing a lot of tweaks on this to really get it how I want, and that's kind of what you expect for $100. So one of the first things that I did is I put in digital readouts. If anyone wants to see an episode specifically on how to do that, I can show you how I did it. And we can go into more on a different episode. But there's, as you can see, there's digital readouts here. I have it leveled and bolted to my workbench here. But after that, that's about it. Now I knew I was going to have to upgrade the chuck because these chucks, you can just watching the end mill, you can see that there is some wobble to it. Even after reseating this chuck on the arbor, I could tell even just by eye that there was too much runout for doing precision machine work. So here is the dial gauge that we have already set up that we're going to be using, and I'll put links in the description to where I got these parts and the part numbers as well in case anyone wants to try to replicate these tests. So we're going to start out with the arbor, then go to this chuck. Now what we're going to be comparing it to today are a few different things. One is using a collet. So this end mill is 3/8 inch on the circular part, which is the part that goes into the collet, and it's for cutting at 11.5 millimeter, and that's the one I pulled out. And it is, if anyone's wondering, it's made by HTC Tool. You can see there 11.5 millimeter, 3/8 inch drive for it, and these are made in the USA. The collet I got from McMaster, and it is a Lyndex Nikken, if that's how you say it, R8 collet for 3/8 inch drive. These set you back about $28 on McMaster, and they're made in Taiwan. And then I went for a very large upgrade. Spent nearly as much on this chuck as I spent on the mill. And this is an integral arbor. As you can see, the arbor is connected to the chuck, keyless chuck, made by Albrecht. It's a very, very nice chuck. It's about $577 on McMaster. It's 1/8 inch to 5/8 inch, or 3 millimeter to 6 millimeter. It's made in Germany. And let me show you the packaging. Since it's the world's best, I guess we'll see. And here is the product information if anyone's looking to look at this online. So we're looking at the runout for these different options. Now, going into this, what do I expect? Collets are made, they're not easy to use because you have to change them out every time you change the drive, but I do expect the collet to perform the best. These are especially very good collets. I think what's going to be worst is going to be the chuck that came with, because the runout looks terrible just looking at it. And I think this really high-end chuck is going to do well, but I just don't think it's possible for these to do well as a really good collet. So without further ado, let's start testing. So let's go over here. As you can see, we're zeroed out. So what I'm going to do is I'm going to turn on the mill. And we're going to spin this real slow. It has a variable speed setting here. And we're going to see this. That's about as slow as it'll go. See how consistent we are here. All right. Looks like we're just about 5 markings. And very consistently. All right. Now, let's put the chuck on and put the end mill in the chuck and see how we compare. All right, here's the setup for the chuck that came with. And what you can see I tried to do is I marked about 6 millimeters up from the end of the titanium nitride coating and put a Sharpie mark there. That's where I try to clamp the jaws of the chuck so it's a fair comparison before it chucks. And I put the Runout gauge right at the intersection there with the titanium nitride coating. See, we're zeroed out on the gauge. We'll start to spin it to see where we're at. Wow, that is big. I'll make sure we're not bottomed out here. This is so big. Looks better. Looks like we're getting a full revolution. Alright, now let's test it right here, just because I'm curious. Alright, so I did rotate this a little bit, so I can get the right range here. And now we're up on the edge of the chuck, as you can see. Just out of interest, let's see where we're at. So, definitely worse than the arbor, but not as bad as at the end mill itself. Alright. In the description, I'll tabulate all these different runouts for interest's sake to make it easier. Alright, now to change out arbors or chucks, what you do is you need to take this rod that comes with the machine. Someone has one of these and just doesn't know how to do this. And you want to feel for when this goes in and locks. Appears to be locked now. That's good. And then we can take our wrench, 17 millimeter. Should have a chance here to get a better camera view. You can loosen it up. What I'll do is I'll take a very light hammer here. See, it's pretty easy, just kind of lightly tapping on it. Okay. Now, when I back it out, you can see it starts to come down. So, I'm going to. All right, and there's the one I just took out. You see the Albrecht there on the left. And now to get it in there, it's just pushing it in, making sure it's keyed appropriately, and getting that drawbar torqued up appropriately for your machine. So I'm gonna go ahead and do that now. All right, well, we're all set up here with the Albrecht chuck. See, we're at the same place on the end mill, and we're zeroed out on our gauge, so close to zeroed out. Let's see how we do. Oh my God. That's incredible. Remember, for the Harbor Freight chuck, we were at about an entire revolution on this gauge. Now we're about 2 markings. It's absolutely incredible. It's a completely different machine. All right, before trying to collet just for fun, just putting it on the side of the chuck here to see what it looks like. It looks just slightly better than on the end mill itself. Pretty incredible. All right, now we have the collet all set up. I have the end mill coming out further from the collet that I normally would for cutting, just to make it a fair comparison, the same amount of stick out as we did for the chucks. So we're zeroed out, so let's see how well it does here. Looks to be slightly better than the. Let's make sure I clean this up. Slightly better than the chuck. That chuck did really well, very surprising. I think for using end mill and for cutting, the extra clearance of using a collet and just not wanting to put a lot of stress on a chuck, I'm going to continue just to use the chucks for things like drilling and reaming, but for the end mill, still want to use a collet. But well, I'm really impressed with the Albrecht chuck. If anyone's got experience with these, feel free to leave a comment below or any. Now, just to give people a feel for the difference in using the stock chuck with the end mill and the Harbor Freight mill, and then using this collet. This was some milling I just started trying to do with it using the chuck, and look at that. And I'm using a lot of lubrication here, trying to go slow, and you can see that that mill was leaving these deep grooves, and you can see it kind of hopping and skipping along here. Just looks terrible. So let's see what it looks like after using the collet. All right, so I just finished up redoing this section here with the collet. So compared to last time, it's really impressive. Made a huge difference. There's still a few things I think I can do with this mill to tighten it up some. There's some chatter marks there, but overall it looks really good. A huge improvement from when I had done it with the mill, with just the stock chuck on there. Changing it with the collet, very stable. Really love it. All right, everyone. Thanks for watching.